Hello my dear students, I warmly welcome you to Sia's digital classes. In this lecture, we are going to discuss about one important problem based on the permutation. Okay, this problem has been repeated in the examination so many times. So observe carefully. So first of all, see what is the problem. If sigma is equal to 1, 2, 3, 4, 5, 6, 3, 1, 4, 5, 6, 2 and tau is equal to 1, 2, 3, 4, 5, 6, 2, 4, 1, 3, 6, 5 are two permutation in S suffix 6. Then compute the first condition is sigma into tau square. The second condition is sigma into tau into sigma inverse. We have to find out these two conditions. Here we have sigma and tau. So to prove the given problem, okay, so we have to find out the tau square first of all and we have to find out the sigma inverse first of all. Okay, the remaining process is same. Here we have another word that is S suffix 6. Okay, start the solution. S suffix 6 is the symmetric group. S suffix 6 is the symmetric group of permutation of degree 6. Here suffix 6 is represents the total number of the elements in that permutation or the highest element in that permutation. Okay, 6 is the highest element. Okay, the remaining elements are less than or equal to the 6. So here 1, 2, 3, 4, 5, 6 and the second row also we have 3, 1, 4, 5, 6, 2. So all elements less than or equal to 6. That number is called degree of the permutation. Okay, now first of all we are solution sigma tau square. To prove this value, so first of all we have to find out the tau square value. So let tau square is equal to tau into tau. Okay, so already we have tau permutation. Okay, so tau into tau. So this is the tau and this one is another tau. So now we are multiplying them. So whenever we are multiplying the two permutations, you have to follow the only one procedure. The arrow mark carried from right to left and from the top to bottom for each and every step. So the first row in the multiplication permutation I am writing trivially because that is also same 1, 2, 3, 4, 5, 6. This first row is trivial. Now the images row I am writing here 1 goes to 2 and here this 2 goes to 4. Okay, so therefore 1 goes to 4, 1 to 4. Next to this 2 goes to 4 and 4 goes to 3, 2 to 3. Next here we have 3 to 1 and here that 1 goes to 2. So that means 3 to 2. Next to 4 to 3, 3 to 1, 5 to 6, 6 to 5, 6 to 5 and 5 to 6. This is the tau square value. So just we are doing that the arrow notation carried from the right to left and from the going to top to bottom. So on that format. So these are the domain values, first row, and the second rows are the image values. So now take that sigma into tau square. So what is the sigma value? And again I am writing tau square. So this is the tau square value. So sigma into tau square, that is equal to, you have to do the same process. The first row is you have to write as it is trivially 1, 2, 3, 4, 5, 6. Now images 1 to 4 and 4 to 5. So therefore 1 goes to 5. Next 2 to 3, 3 to 4, 3 to 2, 2 to 1, 4 to 1, 1 to 3, 5 to 6, 5 to 5, 5 to 6, 6 to 6, 6 to 2. So this is the final value of sigma into tau square. That is the first condition. Next, the second condition is sigma tau sigma inverse. Sigma tau sigma inverse. To prove this condition, first of all, we have to find out the sigma inverse value. Okay. So here you know very well sigma inverse is equal to 1 by sigma. Okay. I am writing that reversal sigma value. So that means we are interchanging the rows. First row in place of first row, second row in place of second row, first row. So that is sigma value. So therefore 3 1 4 5 6 2 and 1 2 3 4 5 6. So that is equal to, after writing that first row to second row to first row, I am arranging the elements in order wise 1 2 3 so on. So therefore 1 2 2 6 3 1 4 3 5 4 6 5. So this is the sigma inverse permutation. The next step, sigma tau sigma inverse. Okay. So now here first of all I am doing this product value tau into sigma inverse is equal to, so write the tau value, this is the tau value, and the sigma inverse value I am writing here. Okay. So this is the tau value into this one is the sigma inverse value. Now I am writing their multiplication. 1 2 3 4 5 6 is the first row, it is trivial. Next 1 2 2 and this 2 goes to here 2 to 4. So 1 to 4, 2 to 6, 6 to 5, 3 to 1, 1 to 2, 4 to 3, 3 to 1, 5 to 4, 4 to 3, and 6 to 5, 5 to 6. Okay. This is the multiplication of tau into sigma inverse. Now I am taking that total problem. So sigma into tau into sigma inverse. Okay. So therefore sigma, substitute the sigma value. This is the sigma value, and tau into sigma inverse value I am writing. Okay. So multiplication. So that implies if you do that 1 2 3 4 5 6 is trivial, and next 1 2 2 2 to 1, 2 to 6 6 to 2, and 3 to 1 1 to 3, 4 to 3 3 to 4, and 5 to 4 4 to 5, and 6 to 5 5 to 6. If you observe carefully, here the domain values and the codomain values both are same. This type of permutation is called identity permutation. Okay. So identity permutation. Likewise we discussed in the group identity elimination. Here also we have identity permutation. So this identity permutation you can denote epsilon or capital I. So therefore the second condition sigma tau into sigma inverse is equal to capital I. In this format, in the examination, if you get the any question based on the permutation multiplication, so you have to follow the same procedure. In the same manner, the same question if they ask in this format, instead of giving the arrow notation, okay, instead of giving in this format, okay, the same permutation they will also ask in this format, and sigma is equal to 1 2 3 4 5 6. Okay, they will ask in the cycle notation. Okay, this cycle notation was introduced in the century 1815 by the famous French mathematician Cauchy. Okay, so the famous French mathematician Cauchy was introduced to this cycle notation in the year of 1815. Okay, to simplify the permutation in the easiest way, or to represent the permutation in the cycle notation instead of writing these two arrow notation. Okay, so here whenever sigma is equal to 1 2 3 4 5 6, what is the meaning of that value means? So sigma is equal to the first row you can write as it is. Okay, for this notation also you have, and here 1 goes to 2, okay, and 2 goes to 3, 2 to 3, and 3 goes to 4, 3 to 4, and 4 to 5, 5 to 6, and again 6 goes to 1. In this format you have to take the permutation. Whenever they ask in the cycle notation, you have to take the original permutation in this format. Just 1 to 2, 2 to 3, 3 to 4, 5 to 6, 6 to again 6 to 1. Okay. So in this format, if they ask in the cycle notation or if they ask in the arrow notation, the procedure is same. Okay. I hope you understood this problem very well. In the next lecture, we are coming with another topic. So practice very well. Until bye. Thank you.